Hi, everybody. I'm Liz Fulton. I'm currently a graduate student at Millersville studying integrated scientific application. Before coming to Millersville, I was an environmental educator locally, focusing on the Chesapeake Bay and Susquehanna watersheds. And way before that, I was an environmental scientist in northern New Jersey. A little bit more about me. I love gardening. These are some columbine flowers in my garden this spring. I also enjoy backpacking. That's on the Black Forest Trail in northern PA, canoeing, and pottery, along with my dog Ziggy, my cat Barley, and my husband Chris. We love to go adventuring and exploring the area locally and just getting out there and learning new things. So, my personal operational definition of STEM is the hands on utilization of a combination of science, technology, engineering, and mathematics to identify and solve complex real world problems by students. As the National Academy of Science, Engineering, and Medicine's video, along with the Vasquez book, point out, I think that the combination of science, technology, engineering, and mathematics is one of the most important aspects to include when defining STEM. It's the connection of these four different disciplines that really makes it more engaging and more easily utilized by students, I believe. The other important factor is the utilization of real-world problems, which engages students and makes the topics more applicable once a student has left the formal education sphere. As Neil deGrasse Tyson pointed out, as well as the Vasquez book pointed out, it's these real-world, engaging, hands-on experiences that really make students connect, and I think makes the information stick around a lot longer once the student is in the, quote, real world, right? So how have I incorporated STEM? Well, in my education program, one of my favorite activities and investigations was the analysis of the health of a local stream. Students completed a biological stream study and collected data on the diversity and abundance of macroinvertebrates, little stream critters, to calculate the health of a local waterway. Then, using that health score and the life history of those macroinvertebrate critters, students predicted the water chemistry results they would find. And that's that picture there on the left. It's students using life history and data they collected to predict the water quality. Then the students would go back to that same body of water, and they used various chemical testing equipment, including a pocket colorimeter, which uses the laser beam to measure the differences in color, Psyche disc for turbidity, and a temperature probe. The students collected water chemistry data. Then, using all of that data along with local land use maps, they identified clean water issues and their potential causes, and then brainstormed various solutions that they and the community could take in order to remediate the issues and improve water quality. Upon reflection of this investigation, I found that STEM practices were utilized more prevalently in the science and engineering categories. Students asked questions to find problems, planned and carried out investigation. They analyzed and interpreted data. Then, using that data, they constructed explanations, designed solutions, and engaged in arguments from evidence. Less utilized were the technology and mathematics categories. Students did learn to use technologies that, while not new in the industry, were probably new to them, and they were technologies that are used by scientists in the field today. Mathematics was a tricky one, but I would often stress the need for precision as the data collected was used by others outside of the organization. So, why is STEM education important? Well, I believe that critical thinking and creative problem solving are essential for an individual to thrive and contribute and build a healthy and just world. STEM education is just one of the ways that we can help cultivate these skills within students. With the climate crisis and injustices that we are currently facing, we need to take bold steps right now to help overcome it. And then we need to help our future leaders with the best tools they can get to continue to slow, stop, and reverse the damage that's been done. And frankly, I think STEM education is one of the main ways that we can help hone and develop these skills. So my goals for this course are to better understand how to effectively utilize and integrate all of these components of science, technology, engineering, mathematics into education. To learn more about the technologies that exist in environmental and watershed education and the ways they're being utilized so I can better support formal and informal educators, and to strengthen my personal educational chops. This is going to be my first education course, and I'm really looking forward to it. And finally, if you know, you know. So thanks, everybody. Looking forward to this class, and I'll see you in the discussion board.